Thank you. Yeah.
Thank you. How are we missing 1, 2, 3, 4, 5 people? That's crazy.
Carson dislocated his shoulder yesterday.
What's that got to do with anything? He'd be sitting there with a dislocated shoulder. I don't see the
think he
issue.
can write with that hand.
So, he could listen, he could block. He could write with his other hand.
I think he dislocated both of his feet as well. And legs, every joint in his body.
Why couldn't Nate be missing today?
I don't know, honestly, I had a Spanish this day that I didn't want to do, so I could have just not canceled it.
Yeah, that's a tough one. That is a tough one. On the other hand, you just have to do it later, so.
Yeah.
Where's his?
Oh, well.
He left you a doctor's appointment.
Actually.
I know.
Well, if Carson's not gonna be here 100% for sure, and we know Hayes is left already. I don't know where Redmond is.
There's not enough people.
Wasn't he here?
In this
No,
So Mark, why don't you move all the way up and sit with Megan?
Hi, Mark.
What am I gonna turn around to? I'm gonna drink water. Not meaning. So does anything.
I still won't
Nate,
forget
I'm
how
gonna
they
just
made fun of me
pause
last
for a
year
bit
for
and see if
having
anybody shows up that I can play with.
Piano.
Don't remember.
Yeah, they're all.
Here's what I have been.
I just entered it into the graph and just gave you the answer.
Look how many votes I put in for the year.
I wanted, I just solve, you can solve for x first.
So I did
The
this first
one
part
plus
of
10 of
the
x,
and
that
then
means the x
I tried a
myself on
different
that side.
form where you just multiply 5 times
So
6
basically
and
just
up
do
to some
10 to
answer.
the log of 5.
So that is that.
Because they're all
Okay.
log base 10.
Yeah,
Because it's not right, it's just 10.
That's
Now
kind of
they'll,
wild.
they just gave
So
you
then
that.
it's just like
So if you see just like that.
times 2.
Oh,
Couldn't you do, sorry, hold on.
I just grabbed it, just gave it an answer.
well, yeah, because
Like
5
all of
times
them?
6 is
Yeah, so
30.
why don't you just,
Well, I chose the first one, I'm gonna see if they're
Well,
all.
I did this so you could see the pattern.
The first one, which is the multiplied.
okay.
But in simplified, my voice has less my voice, and I've been getting like double the amount of
This
voice.
is all the form of y equals.
I'm gonna just put
This
them
is
both on
the
there. I'm
equal for
gonna
x, and then just like replace x with y. Wait, the line just where the
And then I'm
answer is.
running out of room.
But which you can bring up.
Oh, there's too many equalses in that very first one. That
Oh,
should
that
be
one?
times. I don't know why I put an equals there. Because that's just weird. There you go. That changes the answer, I'm sure.
Oh, yeah, we remember that.
Oh, how does it spell again? Oh, okay.
So, I just put it. I think just so that-
I'm not
Right now.
has those answers.
Wait, how did you enter it?
Alright.
Sorry.
So you want to just solve it for x. So this is the equation is like how can you start it? And so this is the basic log to the x.
Oh, I guess I gotta do that one.
You can really do log, right? Oh, never mind. Never mind. You're not gonna do that.
Oh,
Never mind.
yeah, no, I'm good. I'm less worried about the first problem. They're
Oh,
not really related.
That's fine. I can work here.
Except that they're all various things. So, then I'm going to x equal to that.
Well,
You know what x
you know what?
is.
Probably not gonna help. Basically. I mean, we want to do my log work.
that's really cool.
No. Basically, if you start writing like this, let's say like 5 equals
I know.
3 to the x.
That's what it says.
The log, basically, all it does is it gets the x, which is the power by itself. So it's just getting out of the power.
Yes,
What you do is you take the log
It's almost the end of the year.
The other side.
You're perfect.
And then you just rewrite it.
But
So if you wanna write this
Yeah.
back
Smart
here,
as you did.
log base of three.
Kind of average.
What are you thinking, Nate? You got one of them?
That's what I did here. Log base bad.
Let me get that first one.
This is how it works. This whole
Hey,
thing.
here it is.
Okay.
But it's a little bigger. Really long. But this thing that makes it good.
Probably past year. How's that thing?
Nice. I have some cereal.
Cereal? What kind of cereal?
So just-
Yeah, cereal's like the
I was
best.
just solving.
Uh,
It's like a graph.
I can't have very crunchy cereal because I got my
I did this like a
cup.
graph.
So,
So, let's
Did you
see.
test it and see if it
I
worked?
got the name. It's like basically Rice Krispies.
and asking about it.
Yeah.
So if you,
But
if
it
you
was
want
like
some
some
of another log,
flavor.
So like how
Yeah.
Sounds good. I
Rosie?
think I did this right, but it could be very.
This one's doing, they solve for X.
Yes,
And
the reason was that I was just ready to write myself something else.
I think I just need to move that. I mean, his is.
The X is just, they're like, I could have written them like this, but I was just, I wrote all the parentheses and then I put X's in all. So, no, they're not.
This is a very smart man. He just doesn't like shy. He's shy.
Like
He's
mathematically.
smart shy.
He purposely
I
doesn't.
put parentheses and say parentheses X.
So Mark, you're gonna go to the game tonight.
Well, the X is what you're trying to find.
Why not?
How about the game on Monday?
Why not? I haven't been to the game.
What goes in there?
You should go to
So
one.
in other words, so if you look at all of them have got numbers, except for the last one, A and B. So what we're looking for.
Remember we
I
switched
found
X
it
to Y,
anytime.
because we actually had X equals, but we just switched it.
Or the other one.
Whichever one.
You wanna borrow my notes? I have the answer.
Can I take a picture of that later? Thanks, so.
I don't think that's true.
See, look.
I think the log of 5 plus log of 6 is 1.477, but that's not what I'm asking. I want to know what log.
So he wrote, oh, those are two different columns.
Yeah, they're two different.
You just.
They're not the
I thought you
same.
were saying that that was equal to that. I was like, is that?
Okay, when we first
I don't
talked,
know.
that's what I thought too, and I
Find
was
out.
like, what?
And you should talk to Thomas, because he's finding out what the left side is equal to, but now we need to turn that into now what is X equal to make that curve.
Why did I write? I wrote Bob.
Wait, can I see a little thing?
Are you getting?
So what are we trying so far? So you know, let's look at this one, log of 5 plus log of
Yeah,
6
you're
is
pretty good.
1.477. So doesn't that mean that the very first log?
Don't look at this one, this one looks really nice, but that one- that one looks nice.
Log of X, can you figure out what X is equal to? Right, the left side is 1.477.
This is how you draw a good circle.
So what is X equal
It ran into your calculator.
If this,
But you have a very steady hand control all the time though.
how do you know that? I've only, that was like a long time ago. And it
So,
was like
graph
four
them?
drawings or
Oh, you're
something.
ridiculous.
And then the rest were just cringy.
You can't solve stuff with graphs.
but it's so funny when like.
Plus you
you-
get the wrong answer, you're graphing. Good luck. By the way, you have the transform program running, you probably want to shut that off. Program.
Check it out.
Wonder if it's key.
I don't know. I could probably draw better freehand.
Oh.
Very impressive.
Yeah.
But I can draw perfect squares. Check this out.
Oh, yeah?
What that was doing, that would have kept you from drawing more than
Wow,
one
that's
thing at a
a,
time.
that's a tough one right there.
So,
That's a good one.
What's right?
The graphs, I just checked that they're right.
I didn't
You're
say they
right,
weren't
you're
right.
right.
I said you're ridiculous.
You're right, you're right.
I think completely different
They said
thing.
one thing, said it's wrong.
You're solving everything by graphing. It's not even math,
Yeah,
barely math.
uh-huh, uh-huh.
You can just look at your answers.
She looked at my answers and said, and then walked away, so I don't know what that means.
Look for X, not Y.
Or
If he doesn't say anything, that either is a really good sign or it's a really bad sign.
Or it
doesn't
might,
say anything in the
it might just mean interesting.
No, if he doesn't say anything, he just walks away, that's how you know he's about to use your math
He's
as
gonna
a
use your example and be like, this is a learning opportunity.
Sometimes what I like to do as well is I will make a point of asking when it's the correct answer.
Uh-huh.
And it's so fun in algebra classes, because as soon as the teacher asks them something, they just start erasing, because they'll assume I wouldn't have asked them. They'll be like, well, how'd you get that? I don't know. Erase, 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 erase.
They're like, I think I did it wrong.
Oh, I got.
All right, guys. Let's take a look up front. Ryan, x to the a times x to the b.
Ryan?
X to the A plus B.
We all good with that?
Yeah.
Chris David? Cool.
Straight up.
Macia, x to the b divided by x to the a. You good with that?
Yes.
The point of those first two questions, thing one, to remind us of how we simplify exponents. We had a homework not too long ago that lots and lots and lots of people thought x to the 3 to the power of 4 was x to the 7, which disturbed me no end in my honors class, because clearly it wasn't. But mainly to show the idea here is that if we can find shortcuts, then life gets easier. I want to know strategy. I want to know what strategies you use. I am uninterested in the actual answer. I want to know the strategy. How did you figure out what value of x? We're not going to do this last one. Let's call this 1, 2, 3, 4. And when I call on you, I'm going to ask you to just pick one. 5. I'm just going to ask you to pick one and tell me what strategy you used. Because what I want is I want everybody in the class to see different strategies that people tried in order to figure this out. All right? Thomas, pick one. All right, what did you do?
Well, to be honest, I was solving for the wrong thing, and I was typing in my calculator, and I was getting text.
Okay. So what did you type into your calculator, and what did you find?
Log 5 plus 6 equals log 1.477.
Well, careful, careful, careful. Log of 5 plus log of 6 equals 1.477. Agreed? Does not equal log of 1.477. It just equals 1.477. And the question is, what value of x makes that true? This is a good strategy if you recognize that this is not log of 1.477. That's important. This is just a number. Log of some number is just another number. Okay, it's related to powers, but it's just a number. So when you type it into your calculator, you get a decimal equivalent. Thomas, any idea how you could convert that into an x equals? What's the base of log, Thomas? The base of plain old log with nothing written there. What's the base? The base. You remember that one? Ben, what's the base of log?
10.
So how do I rewrite this as an exponential?
All right, which one?
The one that's right here.
would be x is equal to, of course, 10 to the power of 1.47.
Great. That's a good strategy for solving these. You figure out what this number is, and then you've got a really straightforward logarithm problem, which you can rewrite as an exponential. And what is 10 to the power of 1.477? Anyone?
30.
30. Who's got a different strategy? Ryan.
So first I just solved for x. So it took,
What do you mean first solve for x? That's like the last step, because as soon as you
Yeah,
solve for x, you're done.
I wanted to graph it. Just get it by itself, like, and then not solve the other part yet.
Okay, okay. So talk to me.
So
Number 2?
Yeah, sure.
Okay.
So I got x equals 10 to the power of log of 5 plus log of 2. And then I just graph that.
And what did you get?
Got 10. Yeah.
So when you graph that, you just got, whoops.
No, the horizontal. Because it was y equals.
Yeah.
Like, yeah.
Great. Cool. Anybody have a different strategy? Megan?
So
You want to do number 3?
yeah, I'll do number 3.
Good.
So I did like log of 5, I put that in my calculator, and then I don't remember what the number was, but I can do it again if you would like me to.
Sure, sure.
Okay, log of 5, that is 0.698.
Okay,
And then I added that again
okay.
for a total of, hold on, 1.396. Yeah.
Okay.
And then I was like, what if I just did 5 times 5, like log parentheses 5 times 5?
Why did you think that?
Because I wanted to know. I was just curious what it would equal, and it equaled 1.396.
Fair to say that at that point you were starting to wonder if there was a pattern, and then you just tested that pattern and used it on the third one? Cool.
So then it became log of 25.
Any other strategies on any of these? Nate?
On number 4, I remembered that a few days ago we figured out that log of 10 was 1 and log of 100 was 2. And 1 plus 2 is 3, right? So I remembered that log of 3 is 1,000.
No. Say that the other way around.
Oh, yeah, log of 1,000 is 3. That's what
I like that. If you know those two, and then it's like, well, wait, yeah, what log of what equals 3? Hey, wait, I know that because they're patterns of 10, and I know those ones. Cool. Any other strategies that anybody used? Anything different? Do we know what number 5 is? 99. Guys, let me suggest a couple other strategies that you might have used. I like all these, by the way. But let me suggest another strategy that you might have looked at. I'm going to erase a couple of these because I need room. Can't work there. Can't do it. Let me go back to the 5. Log of 5 plus log of 5. Is that, do we agree that that's the same as 2 times the log of 5? Yeah, because when you add something to itself, you're just doubling it. What does the power rule of log say? What can I do with that 2? Yeah, this becomes log of 5 squared. But the problem said that this is equal to log of x, which means that log must be 5, or x must be 5 squared. So if you're taking the same thing to both sides, then things inside have to be equilibrium. So there's another possible strategy that works on only that one. It doesn't work on the rest of them. Here's a fun one. Going back to that log of 10 plus log of 100. What if we didn't remember that that was 1 and 2, but do we agree that 100 is 10 squared? So we could write log of 10 plus log of 10 squared. What do I know about log of 10 squared?
2 log of 10.
2 log of 10, which means that this is log of 10 plus 2 log of 10, which means that this is all equal to 3 log of 10. Oh, but wait, that's log of 10 cubed, which is 1,000. That's another way to think about it. I want to talk about this again for just a second, because this leads us to somewhere interesting that doesn't involve graphing. Can I rewrite that using one of those exponent rules? The top 2? Rosny. Yeah, but I don't know that yet. That's what I was trying to figure out. So I'm going back in time to before I figured that out. You're absolutely right, but before I figured that out. Can I rewrite this using that rule right there? If x to the something plus something is the same as x to one thing times x to the other thing, can't I rewrite this as 10 to the log of 5 times 10 to the log of 2? Agreed? Guys, what's 10 to the log of something? What do you know about 10 to a power and log of that same base? Log base 10. What do we know about 10 to a power and log base 10? True, but not quite there. What do you know about 10 to the a and log base 10 of a? Or just 10 to the something and log base 10 of something? Come on, guys, the whole point of 2 weeks of working with logarithms. Anybody? What do you know about those two things?
It's the same thing.
They're not the same
It's
thing.
not the same thing.
But what are they? Megan?
Are they inverses of each
You asked me or telling me?
They're inverses of each other.
Yes, they're inverses of each other. That was the whole point. Agreed?
Mhm.
The logarithm is the inverse of exponential. But what happens when you take an inverse function to its own inverse? They cancel each other out, don't they?
Mhm.
I'm not supposed to say that.
Not supposed to say what?
They're not, you told it, I can't remember what the other word was for it, but you said it's not canceling.
Oh,
out.
that's completely
It was
different.
something else.
You're right, except that's different. That's a different context. 2 divided by 2, you are not canceling, you're reducing 2 over 2 to 1. Inverse functions cancel each other out. Because that's what inverses do. They undo the original operation. As you had homework problems that asked you this exact thing. What's 10 to the power of a log base 10? If you're focused and paying attention to the homework problems, they're in there for a reason and they mean something. When you see 10 to the power of log base 10, or when you see 2 to the power of log base 2, or when you see happy face to the power of log base happy face, you know what those two things do to each other? They cancel each other out, and you're left with 5 times 2, because that's equal to 5, and this is equal to 2, because 10 to the power of log base 10 goes away. You're left with what was in there. So Ryan's idea of let's just rewrite the equation and graph it is cool, it works. But we can also take the exact same idea and extend it algebraically using powers of exponents and powers of logarithms. And we get that x is equal to 5 times 2, which is 10, which is the problem that he was working on. Rosny, what's the log of a plus the log of b? This is called the power property of logs. Be a good one to write into your toolkits.
Why am I writing it in here?
I don't know.
I don't know either.
Went a little crazy for just a second.
I guess so. I'm just like, oh, I'll just write it in my notes. I often look at the notes too.
Nothing wrong with having it in your notes and your toolkits, because you're going to have your notes there while you're doing your homework. You might not think to flip over and look at your toolkits. Okay, while you're doing that, I'm gonna change this up. You figure out those four? That's not the power property of logs. The power property of logs is the one where you take the power and you put it up by the front. This is the product property of logs, another P word. Change your toolkits. Sorry. Marish, you wanna do one of them?
Yeah, for the first one, I got log of 4.
In agreement? Macia?
So the second one I got log of 2.
Rosny?
Log of 22.06.
Jesse?
Well,
Haven't got that one yet?
No.
Okay. Thomas? Here's another thing I don't like about decimals. A lot harder to see a pattern when you're dealing with decimals. What's 2.5 as a fraction?
5%.
What do you suppose 22.06 is as a fraction? Megan?
375 over 17.
375 over 17. Now, to be fair, your calculator is going to tell you 22.06 when you solve, and your calculator is going to tell you 2.5 as you solve. But when I'm looking at that, if I hadn't given you the first one and the last one, you might have looked at those two, or even if I'd given you 3 more with like crazy weird numbers, and you'd been like, yeah, I have no idea what the pattern is. But as soon as we convert those to fractions, do you guys know your graphing calculator will convert things to fractions for you? Everybody do this. Everybody type in log of 375 minus log of 17 and get the exact decimal on your screen. Once you have the exact decimal on your screen, I want you to push the math button and see the option that says frac.
Yep.
It's a Battlestar Galactica swear word. Yeah. But here, it doesn't mean a swear word. It means change this to a fraction. Hit enter, and it'll convert that to a fraction, your answer to a fraction for you. Does it give you 375 over 17?
It gave me 1.3435.
It gives me a decimal as well.
Yeah.
Yeah, I hit fraction.
I doubt that the decimal was 1. That would make no sense at all. Oh, so it didn't convert it.
No.
Oh, well, wait. Sorry, I skipped a step. Oops. Log of x equals that 1.34 thing, right? We got to do this first. Sorry, my bad.
Yeah. Okay.
So take 10 to the power of whatever your answer is and do not type it in as an approximation. You guys know how to do that?
Yeah.
Go 10, hit the power of key, and then arrow up to the one that you want to take the power of, and then hit enter.
I did it.
And then it'll give you that decimal that Rosneet had, which is 21.06 something.
22.06.
Don't care. And then math frac and see if that'll convert this into a fraction. It doesn't always work because sometimes the calculator itself had to round. Did it work in this case?
Yeah.
Did it give you 375 over 17? That's awesome.
Yeah.
That's awesome. This should do it too.
It has a.
Well, you don't have a math button.
It has a
but-
fraction to decimal button.
But there is a fraction to decimal button.
It's above probability.
It's fine. It's okay.
Oh, wait, here's
Okay. Cool. Anyway, there's a little tidbit for you, makes life easy. So what's the pattern? Log of B minus log of A equals log of
B divided by A.
B divided by A. This is called the quotient property of logs. You got three properties of logs now. You're not generally going to use them when you're just dealing with numbers, because numbers we can just put into our calculator. A lot of these lessons were written prior to having really, really powerful graphing calculators. So you had to be able to do the manipulations. But on the other hand, it's useful to have these properties of logarithms. For example, if I was doing something and after playing around for a while, I came up with the following equation. Log of x squared plus log of 3x equals 27. It's not particularly solvable in that format. But the power property of log says that I could rewrite this as the log of x squared times 3x. And the fact that logarithm can be written as an exponent means that I can write 3x cubed equals 10 to the 27th, which means that x cubed is 10 to the 27th over 3, which means that x is the cube root of that thing. That's not a solvable problem unless you have log properties to be able to combine that into a single logarithm. So it's useful algebraically, even though for numbers we're just going to shove everything into our calculator and it's going to spit out an answer. But as soon as you get algebraic, it becomes a little more complicated. All right? Okay. Let's very quickly convert 17 radians to degrees and convert 390 degrees to radians. Don't forget that when I'm converting from degrees to radians, I want an exact value. In fact, just to remind you, so that you can't say, oh, I didn't know that, I'm going to write the word exact on the board. Can I erase these? Everybody got these? If you didn't, you can get them from your partner. While you're doing those conversions, I'm going to run down the hall with that. So I will be right back. Don't set anybody on fire while I'm gone. Thank you.
city on fire?
Only on Friday.
This Friday?
Tomorrow's Friday.
Oh, okay.
When she's looking at medicine, she drinks her water.
Yeah, but it doesn't make a weird squirting noise.
And I'm just thinking, oh,
You can go for a length. You should go for a length shot on this one. Hold on.
Pass me the bottle. Okay, pass it to me. I'll get out for you, okay? We'll do it from here.
no, squirt it in your mouth. I just need her to make
Yeah,
it.
you can simplify it.
I purposely did it quick. Look at her now. She just,
Ryan, 17 radians. How'd you convert this?
It's the bridge method.
Good, go.
17 radians, top left, and top right is 360 degrees, and under that is 2 pi radians.
And what do you get?
Oh, let me write that one. I got, wait, this can be approximate, right?
Yeah, absolutely. Degrees can be approximate.
974.03.
Does that make sense?
Yes.
How do you know, Nate?
I think about it, and it looks like it makes sense.
I need more.
Okay, well, when we did the thing on the unit circle, there was a little over 6 for an entire 360 degrees. So
So 17 is,
17 is almost 6 times 3.
Okay.
But 974 isn't completely 360 times 3. But
That's-
it's pretty close.
that's the exact explanation I was looking for. When you're doing this conversion, 17 should be something slightly less than 3 full circles. Because we know that there's, like you said, a little over 6 in a circle. So 17 is less than 3 circles. Not a lot less, but less than 3 circles. 360 times 3, 36 times 3, 108, and we get 974. We're a little less than 3 full circles. This goes back to the, you should know your answer before you start. You shouldn't know that it's 974.03, but you should be expecting something a little bit less than 3 circles before you ever start typing into your calculator. So that when you get an answer, for example, if you had gotten the answer, hang on just a second. $3,059. What did I do wrong if I got the answer 3,059?
Didn't divide by pi.
Didn't divide by pi, which means that I probably was thinking it was 17 pi radians instead of 17 radians, and the pi's would have canceled out, but I did it wrong. But when I look at this, I would say, whoa, 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 that's not 3 circles, 3,000 degrees. It's like 9 circles or 8 circles. Immediately I know I did something wrong, and I can go back and I can figure out, okay, what did I do wrong then? This is why it is very, very useful to have an idea of what your answer should be before you ever touch a calculator. Cool. Levi, 390 degrees for radians. What am I going to do?
I haven't been in the short term. This one, 30 degrees is 1/3 pi radians. So apply that by 390 divided by 30, which is 13, and 13 over 3 is 4/3. So what I got was 390 degrees equals 4/3 pi radians.
I I gotta say, Levi, that I couldn't possibly hate that more unless it was wrong. But since it's right, I won't hate on it too much. How about that? Here's what I don't like about that. That's a I figured it out process. That's not a strategy. That's one of these things where you start with, well, I recognized something, that 30 degrees is pi over 3, and that 30 goes into 390, and then therefore I should be able to take some amount of 309, some amount of 30s in order to come up with an answer. The problem with that kind of strategy is that it works when it works, and when it doesn't work, you're stuck. If you had a number that wasn't divisible by 30, now what do? Well, okay, I look at it and I say, well, is it divisible by 45? Oh, wait, is this one divisible by 60? What if it's not divisible by 30 or 45 or 60? You end up getting stuck. And so even though this gives us the right answer, I'm not a big fan of it as a strategy because it involves just sort of diving into your head and saying, well, okay, you know, I know this one thing and I know this other thing. And those tend to only work some of the time. So what Levi did is fine. But keep in mind that if I made it 392, it wouldn't work at all. That strategy. I've got one other little problem with it. What don't I like about your final answer, Levi? Any ideas? It's right, but I don't like the format. What don't I like about that format?
Is it because I didn't leave it in regular fraction?
That's it. Mixed number radians, I don't like them. They're not generally accepted standard. We don't convert radians into mixed numbers. We leave them as the just whatever the fraction is. So had we stopped at 13 pi over 3, that would have actually been better.
Just over 6. Just 30 degrees is pi over 6.
Oh yeah, and then there's that too. Oh, but then it wouldn't be 4 1/6. Oops. Okay. Guys, here's a strategy I really think just works better. Because it works for any angle. Now all I gotta do is simplify. 2, 180, 10, 10, 13, 6. And I'm left with 13 pi over 6. Sometimes you look at a problem and you say, oh wait, look at that. And as long as you get the right answer, it's okay. There's no necessarily right strategy. What I'm trying to point you towards is strategies that will work all the time and never lead you astray. But yeah, there's lots and lots of different ways to solve problems. And for the most part, Levi has worked. We just missed out on the whole 6 part versus 3 part, which I didn't catch. All right. Cool. So I'll let you in on a little secret. Last week, I planned out 2 weeks of Honors Algebra 2. I planned out all this week and I planned out all next week. And then on Monday, I came in running late, not having slept well Sunday night, and I taught you next week. By accident, because I didn't look at my planner book. So now, in case you were wondering why we did logarithms last week, but then we waited till Friday to do the the product property and the quotient property, it's because that was what we were going to do Monday. And then we were going to do a bunch of other stuff all this week. And then we were going to come in on Tuesday and we were going to learn about unit circles and the right triangles and all that stuff. And I realized it Monday after you guys left, and I was sitting over there and I opened my planner book to make sure I had everything. And I was like, oh, you got to be kidding me. You may have also noticed, some of you, that I kept putting the same homework in day after day after day and then going back and changing it because I was just so discombobulated. It wasn't a great, last week was rough. This week's been better, but last week was definitely rough. So the reason I'm standing here, not teaching you anything very briefly, is because I was trying to figure out where to go next. Because I got two things to do with you. Yeah, let's do this. Open Desmo. Yes, ma'am. You may. Why don't you type that into Desmos?
Okay.
You will want to go over into settings and choose Radians. Settings is the little thing that looks like a gear. In case you didn't know. It has the option radians degrees. You just click on radians.
That's under,
That's for the, that's,
Whatever. Do I look like I care? There.
because you don't know. It's not in its word. You don't care.
Wait, why is there an option to put it in Braille mode? Does that like make bumps on the screen?
I have no idea.
No, it just dots.
Oh, it's a red.
Dots.
Oh, okay. So yeah. So guys, here's what Braille mode does. Macy just pointed out, it just puts dots all over the place. What you would then do is you would print that out on a Braille printer, and a Braille printer just punches the dots into a paper, and then you can run your fingers over it and read it. So yeah, so that's interesting that's cool that they have that.
They're very considerate.
You'd have to have a Braille printer, but I'm assuming that you would have a Braille printer hooked up to your computer, and then you would just print out anything you needed.
Yeah, so they can read it.
How much is,
How do blind people know where to put their hands on Braille? Like,
Probably same reason you know where to look to start reading.
well, there's signs.
Top left.
But they can't
Signs
read it
on the
unless they touch
wall,
it.
but then like, they just go like this on the wall till they find it.
Probably. Everybody got sign of X?
Yes.
Go ahead and hit the home screen. How big is your graph? How many cycles do you see? Hit the home button.
the home?
It should, that's only if you're zoomed out.
3 full cycles.
You see 3 full, all to the right?
Oh, I was saying both sides in total.
So we see 1 cycle here,
That's over two.
and then
Yeah.
like that.
It's
Ish.
kind of flipped the other way, but
It better not be flipped the other way because that's the graph of sine.
Yeah, I see
it's not
that.
flipped. It's just like it starts slightly more that way.
It better not because it starts at 0 because this is the graph of sine.
Yeah, I know, but there's one more bump, like so.
Oh yeah, I don't care.
Yeah, it just
Okay.
makes sense.
Okay, thanks for telling me, but I totally don't care. My question was just purely how does it size the screen, and that's close as if it looks something like that. I wanted to make sure because I didn't know, because if you make your screen too tall, you're going to get something that looks like that, and that's not useful to us.
Wow, it looks so similar.
Guys, I want you to shift this up or down by K.
Up and down like that.
Yeah. Thumbs up if you got it to shift up or down by K. Thumb to the sideways if you're still working on it. I see lots of thumbs upses. Cool. Where is it?
Like in the equation.
We're in the equation.
Oh.
At the end, so like that?
No.
Yes.
No, like parentheses and then plus K.
Aren't I annoying?
No.
It's like, come on, Miss Harmony, you knew what I meant. All right. I want you to shift left or right by H.
Shift left or right. Oh, that's nice.
Give me a thumbs up if you got it.
Yeah.
Where does it go? After the X? Oh, you know what I'm gonna do if you say that. Aha, aha. I think you guys would learn, wouldn't you? And not keep saying the same thing, which allows me to just be ridiculous.
Well, you said, where does it go? I want to
Yeah.
go minus X.
Where does it go?
Minus 18.
Hey, I want you to make K equal to 0, and I want you to make H equal to negative pi over 2. What do you notice?
Negative pi over 2.
H equals negative pi over 2.
Oh, so then just do. Get over there.
Bless you.
Bless you.
What does it look like?
It's kind of weird.
Like the x of the first curve is on the y-axis.
Guys, do you agree that if I shift this to the left by pi over 2, that this now starts here? And that'll be there, and this will be here, and that'll be there, and so now the curve looks like this. What's the equation of that graph? Minus negative, right? Because we're moving it to the left. What's another equation of that green graph? Anyone? Does that look familiar, that green graph?
Oh, yeah. What was that?
Oh, yeah.
What graph was that? What was that?
Definitely not tangent, because tangent had asymptotes, right? Because Rosny, cosine. This green graph is also the cosine of x. Turns out that cosine is just a transformed sine graph.
That's crazy that you just picked that number randomly and that's what it was.
I know, that's exactly what I
That
did.
is talent right
Just
there.
totally picked a random number. I am, in fact, a random number generator in my spare time.
Wow.
People call me for $5 a minute and say, give me a random number.
Oh, I usually just ask Siri.
Because I'm better at it.
You paid like
Siri
$7.
sucks.
Makes
Plus-
it more personalized.
She literally just waits. She's like, hold on, give me a second.
See, Mr. Omni wouldn't make you wait. He'd
He
be
does
like, here
it
you
for
go.
$5. Siri does it for 700.
Exactly.
True.
Hey, do you want to hear a fun story about things that listen to you all the time in your house?
Alexa,
My buddy has an Alexa. I will never have something that listens to me in my house. I have it shut off on my phone, and I have 0 things that listen to me all the time in my house because I do not want people listening to me all the time. My buddy is working in his kitchen. I was down there at their house. They live down in Monroe. And he was getting frustrated with something, and he starts swearing up a storm. And somehow Alexa activated and said, I don't think that language is appropriate. It was awesome.
No way.
It was awesome.
I heard about Alexa, like there's like, I don't know if this is true or just like a story because Alexa listens, but there's like a crime like in a house and they like asked Alexa and she like responded and like knew what happened.
Wouldn't surprise me. Having something that listens to you all the time in your house, I don't know. Hey, how do I stretch or compress y equals sine of x by some stretch factor a?
I know. I do know. I'm just so smart. Ooh. There's just tricky.
Where does it go?
Before the sign.
In front of the sign, so y equals a plus sine of x.
Well,
No.
your heart feeling like that. It's like, like the wide graph.
Yes. We just multiply that by a. Guys, let's put this all together. Let's put it together. 3 transformations.
3 transformations.
Parent. Y equals sine of x.
Should we put this in our
Transformed. Y equals a sine of x minus h plus k. We might not be ready for toolkits quite yet.
Yes,
Yeah, I don't have space
So I don't know.
for another.
Should have planned ahead better.
write it on the margins.
We'll worry about that later. We'll worry about this toolkit later. We're not ready anyway.
Okay.
So don't put this in your toolkit.
Yes, sir.
Because I got a question for you.
Yes. I know that one.
There's your basic graph, agreed?
Yes.
I can now make it taller. I can now make it shorter. That's A. I can now take the whole thing and slide it left or right. That's H. I can now take the whole thing and slide it up and down. That's K. Would we be listening, please? But here's my question. None of those 3 transformations that we just talked about would allow me to make it go faster. So here's my question for you. Where could I put another transformation into this function that would make it go faster? Talk to your partner.
Like this.
I don't know. Yes. I think so too. Yeah, so go from purple to blue.
Oh.
I think. Let's try it. So this is our original equation. If you do this in if you see the whole thing or just
X to the power. It's not the same graph anymore.
Trying to get this back to normal.
well, how do we take out H and K?
wait a minute.
Okay, this.
Yes.
Okay, I don't think the next one works. I don't know, I just added B. And I guess I don't like B. What is that? Look at that, what is that?
All right. Here's a question. What things did we try, even if they didn't work? What did you try? Cameron.
A number divided by x over some number.
So like that? Ozzy?
You multiply something by x.
Cameron. What happened? What number did you put in there? Give me an example, and what did it do to the graph? Because we wanted to get it scrunched in, right? So what number did you put in there to get it to scrunch in?
0.5.
So sine of x over 0.5, scrunched it in. Okay. What number did you put in there to get it to scrunch in, Rosney? So those both did the same thing? That seems.
It was actually 3.
Oh, okay. Okay. Guys, do we agree that dividing by a decimal is the same as multiplying by a whole number? Because multiplying by the reciprocal?
Mhm.
So
Yeah.
dividing by a half is the same as multiplying by 2, right? So if I wanted to use Rosne's strategy and Cameron's strategy, I would just make that a 2 and I would get the exact same graph. Yeah?
Uh-huh, yes.
We're actually going to go with this strategy. We're going to use the multiplied by something. So then the question is, how do I get it to be longer? What do you think I put out here to make it longer? Play.
Make it long. Oh, wouldn't it just be? What if it's only 5? Yeah, you would just. Do this one is 6, right? Every time we talk about decimals, that's what I think of. You're welcome.
What do I need to put here to make this longer? Negative? Got one theory that if I put a negative in, it'll stretch it out.
Well.
I'm a little skeptical on that one because we had a homework problem some time ago where we had to plot f of negative x. You guys remember that homework problem? I asked you to plot f of x equals absolute x, and I asked you to plot f of negative x, which would be the absolute of negative x.
Oh, mine just scratched it. Whoops.
And what did it do? Anyone remember? Actually, there was a transformation. It was like +2 or -2 or something. So it was over here.
Uh-huh.
There was f of x. What did f of negative x do? No, it totally did something.
I think no, the other one. There was 2. The other one didn't do anything.
Yeah, it totally did something. If you did the problem right.
Didn't it just flip up?
No, that would be negative f of x, which is not the same as f of negative x. Yeah, it came over here. This was a y-axis reflection. And this is an x-axis reflection. And sort of goes back to, if you're wondering why these problems pop up in the homework, they're there for a reason. So thinking about what they're asking you to do is useful. I had a lot of people turn in that one with one graph. It was just like, well, where's the other one? What other one? I didn't know what it was supposed to be.
I think that was me. I'm pretty sure that was me.
So how am I going to stretch it out? Macy? Oh, Cameron? Yeah. If I put in some value of b between 0 and 1, okay, that's completely hard to see, probably.
It's not that bad.
This is going to be a stretch. But notice that these are horizontal stretches, not vertical stretches. These are both horizontal. So let's talk. You're going to need your graphing calculator. You can use the one in Desmos, but I want you to have your graphing calculator because we're going to play around a little bit with this equation, y equals sine of bx. And here's what I want you to do in your graphing calculator. I want you to open the window button. And I want you to make the x go from 0 to 2 pi.
Okay.
And I want you to make the y go from -1 to +1. So your axis will look like this. And there's pi, and there's 2 pi. And if you want to make the tick marks, make x, oh, what's that called? Yeah. X scale equal to pi over 2. So I want your x's to go from 0 to 2 pi. You're in the window screen right now in your graphing calculator. Push the window button. And I want your y's to go from -1 to +1. I want your x scale to be pi over 2. Everybody there?
Wait, where's the pi over 2?
X scale, X SCL. It's right below the X minimum X maximum X. Did you find it?
Yes.
Okay, cool. All right. Here's the information that I want you to collect. I'm going to give you a variety of graphs to make. And for each graph, I'm asking you to find certain things. Here's what you need to find. For each graph, I want to know number of cycles on screen. A cycle is one full rotation of the unit circle. Okay. I want to know the cycle length of each cycle. So in other words, from left to right, how long is that full cycle? Okay, so your first equation is y equals sine of x. How many cycles are on your screen and how long is one cycle? When you figured that out, well, let's talk about that one first and make sure everybody understands what it is we're asking. Oh, is it 12:38?
Yeah.
Okay, well, tell you what, we'll finish this conversation on Tuesday.
Alrighty. They're not the only ones I'm playing against.
Don't forget not to come to school on Monday. Thing one, the bus won't pick it up.
Aaron, come.
Yes.
Oh, you're not even up to Yeah.
You can't get mad at me. I wanted more education.
One more education. You can come to school by yourself.
Yeah,
And teach and learn.
I'll educate myself.
I believe you. Believe in you. I believe you.
Not on like actual subjects, just like weird experiments, seeing how hard I can smash my head into a wall.
You know, like something fire.
It's like papers.
All right, guys, have an awesome weekend.
Bye, Sarah.
Bye. Memorial Day. Logarithms, last week. You're welcome. Bye. Calvert. Hi, Grace. Hang on just a second. I've got to see what I've got a meeting. Unfortunately, it's starting in about 5 minutes. But I could maybe later this afternoon if that worked for you. Okay, do you want me to call you back or? I don't know. I know I'm a high school teacher and I know I've got got a meeting now, and then we've got some training later on, and I'm not 100% sure when it all ends. But probably sometime around 2:30.
Yeah.
Okay, I'll give you a call back.
Very true.
Thank you.
Hey, I just thought I could be possible.
Howdy.
Thank you.
Betcha. Hi, Avery.
Hi.
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 Wow. Oh my gosh, that's a giant bag of.
I know.
They should give you a backpack to go with.
They give us a ton on Fridays. I kind of want to do calculus, but I didn't put it in my schedule.
I don't think the council will approve that. I think they don't like people just changing their, now, would you be changing your schedule, or were you thinking about doing it up at the college, and now you're gonna think about sticking?
No, I didn't have it in my schedule.
Gotcha,
Yeah.
gotcha. I would just go, who's your counselor?
This is like right.
Ah, darn it.
I know.
Yes, we all know who's easy and who's not. I would just stick your head in and just, I mean, blame it on me.
Okay.
I was talking to Mr. Armitage, and he really encouraged me to take calculus, and I'd love to get my schedule changed. And that way, she'll be just like, oh, darn it.
Perfect.
All right.
Okay, thank you.
You betcha. yet?
I need you right there. Take whatever, just, like, probably would have freaked out even if I was over.
Yeah. Oh, totally.
You cheated a customer out.
Yes.